Welcome to today's lesson, which is called Staying in Balance, and it is about balancing equations. And we will be using balanced hangers to represent equations. The goals of today's lesson are that you can explain what a balanced hanger and a true equation have in common, and that you can write equations that could represent the weights on a balanced hanger. So here we have two hangers. One of them is unbalanced, the one on the left hand side. Unbalanced meaning one side of it is heavier than the other side, so it weighs down on that side. On hanger B, it's balanced, and you can see that 3 of the blue boxes were needed to balance one green triangle. So let's write an equation to represent a hanger. So here in the center, that represents the equal sign. And on the left hand side, we have 3 x's. So I'm just going to write 3x. And on the right hand side, I have 1, 2, 3, 4, 5, 6 times 1. So I could just say 3x equals 6. That's the equation to represent the hanger shown here. So here we have another hanger. Again, we have an equal sign. On the left hand side, we have a y and 3 ones, so y plus 3. And on the right hand side, I have 1, 2, 3, 4, 5, 6 ones again, so y plus 3 is equal to 6. To solve an equation, we need to keep the hanger balanced at all times. So let's see if we can match up what's on the left hand side with what's on the right hand side to solve this. And we saw this same hanger 2 slides back, and the equation was 3x equals 6. So let's look at matching up the x's to see how much 1x represents, matching up the x's with the numbers on the right hand side. So here we have an x. I'm going to match it here and here. And going to start with this x, match it here and here, and so each x matches to 2 ones, so the solution to the equation is x equals 2. And so we can say, we talk about truth in equations, that 3x is equal to 6 when x is equal to 2 in this equation that we're shown here, in this hanger that we're shown here. 3x equals 6 when x equals 2. Let's solve this equation, and we saw 2 slides back that this is y plus 3 equals 6. And we can't just match up the y with the ones on the right hand side, because you have ones on the left hand side as well. And we want to end up with y equals some number, and we can't just start taking away the ones from the left hand side, because it would unbalance the equation. It would be like this. Actually, it would be the other way around. The right hand side would be heavier if we take away ones from the left hand side. So we need to take away one from each side. So let's start matching them up. So we could take these 2 away, and then we could take these 2 away, and finally, to get rid of the last one, we could take these 2 away. And now we're left on the left hand side with just y. So we can say y is equal to whatever is left on the right hand side, and we can count 1, 2, 3. There are 3 ones left. Y is equal to 3. So to summarize, the hanger must always be balanced. If you remove something from one side only, the hanger will be unbalanced. you must remove the same number from both sides for the hanger to remain balanced. So to recall today's goals, you saw what a balanced hanger and a true equation have in common, and you can write equations that could represent the weights on a balanced hanger. And that's the end of today's lesson.